Welcome to The Explainer. So today, we're going to break down something absolutely fundamental in machine learning. How do we build AI models we can actually trust?
Okay, so let's dive right into this. The whole problem isn't just about, throwing a bunch of information at an AI. It's about making sure it's actually learned something so it can go out and solve new problems, not just memorize the answers to the old ones.
And the secret really is all in how it studies. It's a pretty clever solution, and honestly, it's kind of borrowed from how we humans learn. We don't just give the AI all the study materials at once. Nope. We get strategic. We split all that data into three completely different sets.
All right, first up, we've got the training set. Just think of this as the AI's main textbook. This is where all the heavy lifting, all the initial learning really happens.
So this is the biggest piece of the pie, usually like 70, maybe 80% of all our data. And the model just goes over this data again and again and again. We call those cycles epochs. And it's just trying to find all the little patterns and connections. Every time it does, it tweaks itself a little bit to get better at whatever we're asking it to do. And this is where that whole student analogy really clicks, right? The AI model is our student. And this giant pile of data, well, that's its entire curriculum. Everything it knows, its whole foundation, comes from studying right here.
But, just reading the textbook over and over isn't really enough, is it? You gotta check for understanding along the way. And that brings us to our second super important data set, the validation set.
Now, this is the key thing to get. While the model is busy studying its textbooks, that training data, we're secretly giving it little pop quizzes with this different, unseen set of data. The model doesn't get to learn from this quiz, okay? It's not changing its core knowledge based on the results. This is purely for us to check in and see how it's doing. And the model's grades on this practice quiz, they are so valuable. They help us, the people building the model, to tweak its overall study strategy. We can change things like how fast it learns or how complex its thinking is. We call these high-level knobs hyperparameters. And this whole process lets us tune everything up perfectly without giving away the answers to the final exam.
So that brings up a really important question. What happens if the model just memorizes the answers from the textbook? Well, this leads to a huge critical problem in machine learning. And that validation set we just talked about, that's our first line of defense against it. The problem is called overfitting. Yeah, it's exactly like that student who gets a perfect score on all the homework just by memorizing the specific questions and answers. But then the final exam comes, the questions are a little different, and they just completely bomb it. Why? Because they never actually understood the concepts. They just memorized. And this chart shows it perfectly. Look at that. You might see that 99% training accuracy and think, wow, we did it, success. But this is exactly where you have to be careful. When you see that huge gap between the training score and the validation score, that is a massive red flag. It's screaming at you that your model has just memorized the textbook, and it's probably going to fail when it sees new stuff out in the real world.
Okay, so our model has studied its textbooks, it's aced its practice quizzes. Now it's time for the big one, the final, ultimate evaluation.
And this is maybe the single most important rule in this whole process. The test set is completely separate. The model has never, ever seen this data before. Not during training, not during tuning, nothing. It's been locked away in a vault just waiting for this moment so we can get one final, totally honest grade on what this model can really do. Think of it like a proctored final exam. The answers are in a sealed envelope. The score it gets here, that's our best guess for how well it's going to perform out there in the real world when it's faced with stuff it's never, ever seen before. This is the moment of truth. All right, so let's just do a quick recap. The training set, that's the textbook. It's for learning the patterns. The validation set, those are the practice quizzes. That's for tuning the model and spotting if it's just memorizing. And the test set, that's the final exam, the one unbiased final grade.
Okay, so this all makes sense in theory, right? But what does it actually look like when you're, writing the code? Let's take a super quick look at an example from Keras, which is a really popular tool for this.
So in a framework like Keras, you've basically got two easy ways to handle this. The first one is validation split. It's super simple. You just tell it, hey, carve out 20% of my training data and use that for validation. Easy peasy. The other way, validation data, gives you a bit more control. This is where you provide your own completely separate pre-made validation set, for when you want to be extra precise. And that really leaves us with one final thought, doesn't it? So if a model gets a perfect A+ on its final exam,
Is it truly ready for all the chaos and complexity of the real world? Passing that test is a huge deal for sure. It gives us the confidence to let our model out into the wild, but we have to remember the real world is always messy, it's always unpredictable, and it's always changing. It really is the ultimate, never ending final exam.